plot to open. Hello everyone. So today we're gonna do a tutorial using Adams View version 2024. On the tutorial we're gonna work on is a stone that is falling under the influence of gravity. So basically we're going to find the displacement, the velocity, acceleration of the stone after 1 second. So when the stone with an initial velocity that falls under the influence of gravity. So we're going to create a model using Adams and then simulate it. So you can see these two bars open here on Adams on the screen. We have new model, existing model, and then exit. We're going to create our new model. So you go to new model, click on new model, and a new box opens that says create new model. So the model name, that is where we're going to put the name we're going to give to our model that we're going to create. Then we'll maintain gravity to normal Earth. We'll maintain the unit. So now let's change to our name for the model, which is falling stone, falling underscore stone. And we also have the working directory. The working directory is basically where we want to save our work, where we want to save our model. So let's say, for instance, we created a folder somewhere that we want to save our work in. Then we go to this folder icon here, click on it. Then we browse for the folder where we want to save our project. Come to Documents, and we have the Adams folder. That's where we want to save our project. Click on it and then select folder. Now that our directory has been selected, just click on apply. Sorry, click on OK. Now we have our Adams software opened. That's the working grid, and we have various toolboxes here we're going to use to create our model. So the next step is to build the stone. So in building the stone, we go to the solid toolbox to select the sphere, which will be used for our stone. So select the sphere. Now when you select the sphere, we have new part and a radius. New part and a radius. So here we're going to make sure that the radius is checked and assigned our radius value to our sphere. Our radius value is 5 centimeters. 5 centimeters. Now we set our radius value to 5 centimeters. Now you come to the working grid, to the center or the coordinates, to the origin of the axis, and click on the origin. Then you can see that our sphere has been created. That means our stone has been created. After building our stone, we have to rename the stone. After rename the stone, so you come to your working grid, right click on the stone created. You go to parts, and then you locate renaming. Select renaming. So when you select renaming, this toolbox open with object and new name. So under new name, that is where you're going to give the new name to. That's where you're going to rename our stone, which is falling stone. We'll click on apply. Sorry, click to rename it again. Rename. Falling stone. And click on OK. Now our stone has been renamed Falling Stone. Stone has been renamed. So we're going to assign physical properties to our stone. That's where we're going to assign the mass of the stone to 1 kilogram. So again, you go to the stone, right click on the stone, you go to parts, and then you select modify. So when you select modify, this toolbox opens where we have different text boxes. We have the body category defined by mass, the material type, density, the properties of the material being used. So in here, we go to define by mass, the drop-down menu, and we select user input so that we input our own values in there. We're going to set the mass of the stone to 1 kilogram. One kilogram. Now we've set our mass to 1 kilogram. Click on apply, then OK. Then OK. So from our tutorial problem, we're supposed to find the displacement of the stone, the velocity, and then the acceleration of the stone. So now this is where we're going to calculate for our displacement, our velocity, and our acceleration. So again, you go to the working area where the stone is, right click on the stone, go to the parts. This time you locate measure. Click on measure, and you have this toolbox opened. This toolbox opened. So in the toolbox, we have measure name, we have parts, we have characteristics, components, and then represent coordinate in. So what we're going to do now is in the measure name text box, going to type in displacement to show that we are going to measure for displacement. And then we maintain the CM position for the characteristics. For the component, we select the Y component because stone is dropping vertically downward. Then we make sure that create strip chart is ticked or is checked. You click on OK. Clicking on OK, you can see that this new plug toolbox has been opened. It was supposed to display our displacement at the top because this is supposed to measure for the displacement. Looks like it did not happen. So we can come back in here where we have our measure. Then this is the first strip chart that has been created. And right click on that, go to rename. Then under new name, you type displacement. Rename the title of the plot as displacement. Then okay. Now we have displacement at the top to measure for our displacement. Our next step is to verify our model. So we can come under the right bottom corner, locate this icon that looks like an eye for information, right click on it, and then select the verify the model icon. Now we can see that everything has been verified. It says here that model verified successfully. That checking that, we can just close it and continue with our work. Now that our model has been verified, we can set up the model and then run the simulation of the model. For easy viewing, and so to make sure that we can see the ball falling, during our simulation. Simulation. We are going to zoom in. Zoom out, sorry, to make sure that the grid is smaller enough so that we can see the simulation or the animation of the stone falling. Bring it at the top corner. Okay, now everything has been set up. We're going to run the simulation. So we come to simulation on this two bars. Click on simulation. And we select interactive simulation. So in our interactive simulation toolbox, we have end time, we have steps. We're going to select 1 second, which is the time, which is what we're supposed to find in our tutorial. 1 second. And then our steps is 50 steps. Then we check reset before running. Now that all this has been done, we can run our simulation successfully. All you have to do is click on play. Now I believe you could all see a simulation working. The stone falling, okay? So on our displacement plot, we can right click on it. We have plot SCHT1, which send us to a drop-down menu where we select transfer to full plot. Then click on that, wait for the post-processing. Now we have our post-processing plot opened. Post-processing plot opened. Now we're supposed to define the displacement of the stone after 1 second, right? So we're going to choose this icon, which is plot tracking, to track for our time. The X component is the time, and then our vertical is the length, which is our displacement. So for a time of 1 second, which is here, our displacement can be displayed. Our displacement can be displayed at this box. So at a time of 1 second, as you can see, it is negative 4903.3271. There's our displacement for the stone falling on at 1 second, falling under the influence of gravity. Or we can go through the same process to find for the velocity. Okay, so that you go to the working grid, right click on the stone, go to part, select measure, then measure name, we type velocity. For the characteristics, we choose cm velocity, and then for the component, we choose y. Also make sure that create strip chart is checked, and then okay. You can see that our new plot has been opened, but the title is not velocity. So you can come to measure and then rename it from there. Go to rename. Velocity. And okay. Now we have our velocity plot. Now we can run the simulation again. Go to iterative simulation, same values, then run. Yeah, so now we have our velocity plot. We can repeat the same procedure for our acceleration. Just go through the procedure I just went through. All you have to do is the characteristics. Instead of choosing cm velocity, choose cm acceleration. And you can also find out about your acceleration. So this is the end of our tutorial. Thank you very much.